This is Dr. Sriidharan from SNS College of Technology. In this lecture, we are going to see about the corrosion control. The rate of corrosion can be controlled by either modifying the metal or the environment. The factors affecting the rate of corrosion, especially for the nature of metal and nature of the environment. The control of corrosion by modifying the metal by selection of the metal or alloys, by using pure metal, uh, by using proper design. By selection of the metal, selection of right type of metal is the main factor for corrosion control. Novel metals are used in the ornaments and in surgical instruments as they are most immune to corrosion. The rate of corrosion is very less in this context. By using the pure metals have higher corrosion resistance than that's a impure metal. Even a small amount of impurity may lead to severe corrosion. By alloying, corrosion resistance of many metals can be improved by alloying. For example, stainless steel containing chromium and nickel produce a coherent oxide film which protects the steel from further attack. By proper design, some of the important rules for designing which must be observed are given below. Avoid galvanic corrosion, avoid sharp corners and edges, and drainage affects corrosion, avoid crevices. The first one, the galvanic corrosion. How to avoid the galvanic corrosions? If two different metals are joined, galvanic corrosions will occur. In such a case, galvanic corrosion is prevented by selecting the metal as close as possible in the electrochemical series and providing a smaller area for cathode and larger area for anode. Inserting on insulating material between the two metals. Here the diagram shows the proper design as well as poor design. The poor design is there is no barrier for the dissimilar metal. In the good design, we use it for the insulations, so there is the direct contact with the metals. And here is another one of the design. The poor design is we keep it on the aqueous medium in the container, so there is no provision of the drainage systems. We don't apply for any other kind of design aspects, so use for only the container. Whereas a good design, we provide for the drainage, the proper drainage. It helps to prevent the corrosion. Avoid sharp corners and edges. Corners and or edges should always be avoided, and hence corrosion can be avoided by smooth corners and curved pipe planes. Drainage affects corrosion. Tanks or other containers must be designed in such a way that the whole of the liquid should be drained off completely. Avoid crevices. Crevices allow moistures that which result in increased electrochemical corrosions. This can be prevented by filling the crevices with a filler. Here the diagram shows the two joining of the pipelines, so that the joining having the crevices, that crevices filled with the some fillers to avoid the crevices type of corrosion. And next one, the by cathodic protection. The principle involved in the cathodic protection is to force the metal to behave like cathode. There are two types are available: uh, the sacrificial anodic protection and impressed current cathodic protection. The first one, the sacrificial anodic protection method. The metallic structure to be protected is made cathode by connecting with a more active metal, so that all the corrosions will concentrate only on the active metal. The remaining place is safe. That means behaves as a cathodic part. The artificially made anode thus gradually gets corroded, protecting the original metallic structure. Here the diagram clearly explain about the cathodic part and anodic part. The first one is pipeline. Buried pipelines behave as a cathodic part, and here used for the zinc as a anodic part. Similarly, for the ship hull also we use it for this kind of approaches. The place the zinc metal or carbon like materials. And another one of the type is impressed current cathodic protection method. The impressed current is applied in the opposite directions of the corrosion current to nullify it, and corroding metal is converted from the anode to cathode. This can be done by connecting the negative terminals of the battery to the metallic structure to be protected, and the positive terminal of the battery is connected to on the inlet anode. Here we supply the DC power supply. The positive terminals connected to the inlet anode, and negative terminals connected with the safer side of the safeguard of the structure, metallic structure. The inlet anodes used for this are graphite or platinized titanium. The anode is buried in a backfill. The backfill provides a good electrical contact to anode. This diagram shows the type of impressed current protection. We purposely do it for these connections, like 90 terminals connect with the underground pipeline, and another connections the positive terminals connect with the graphite anode. Structures like tanks, pipelines, transmissions line towards underground water pipelines, oil pipeline ships can be protected by this method. Thank you.